was like, underclassmen. Your class when they were underclassmen. Maybe your class now. Anyway. I desire good things for you. And one of my big prayers is that you pursue those good things for yourself as well. Shh, shh. I don't know. Okay, here we go. Question. You guys just took, hi Justin, and anyone else who's gone? No. We just took notes on these 2 pages. I think we started some on Friday. I think we started the discs. We just didn't get the washers. So they were copying notes, and now they want to see their tests, even though it looks really messy how I graded it. But I'm going to go do that, and to do that, I'm getting them on an example. How do you know if it's a disc or a washer? Flush or not flush? So you have to picture the area being revolved. True? You have to picture the area being revolved and whether it's flush or not flush. Yeah, you can graph 2 plus x cosine of x. I think it was there and I just didn't take a picture of the picture. Radian mode, true? Wait, how do you not get confused? How do you put an interval like this into your calculator? Window, x min, -2, x max, +2. True and right went together to be trite, and that's not what I meant. True? If you don't have a calculator, peek on with someone because you're going to want a picture because you need to think about if it goes all the way to the x-axis. My guess is flush because if it goes all the way to the x-axis, but a picture will help. A picture will help. Get a sketch. Shade the area of the region that you need to be revolving, asking yourself flush or not flush, to account for the hollow or to not account for the hollow. That's the question. Oh my goodness, aren't you guys doing Hamlet next? Oh, right, sorry. Cute, I like it. Sketch. Crazies. Sorry guys, quick school thing came up. Are you guys collaborating in your groups really quickly to make sure you agree? I have another example we can go on to. You guys got it? You agree? Ooh, okay. Okay, I know it's okay. 6 something each. All right, let's see. Who has a picture for me? So I should be able to tell this. 1, 2, x cosine x. Isn't it something like 1, 2, x cosine x would be... Is it something like that? The other way? Oh, because it starts at the top? Something like that? Ish? Anyway, whatever it is, long story short, is it flush? Okay. So whatever it is, it's something flush, and it's between -2 and 2. So as soon as we knew it was flush, do you really need to know much more about the actual shape? Oh, well, that's awkward. Really? Because what do you really need to figure out? The top bound and the bottom bound, right? Since that area is flush, when you rotate it about what line? Always very important in these types of problems. Which is why we can say flush, because it's completely against. When you rotate that, give it some depth. Is this a dx or a dy? Dx. Volume is equal to 1/2 pi times what? -2 to 2 dx squared. Technically, 2 plus x cosine of x minus 0. Why am I showing you minus 0 if minus 0 has no bearing on the actual answer of this problem? To show the minus 0, this is the spot where I would put the bottom bound. What if I was instead going around y equals -1, or y equals, actually better in this case, y equals 1 or y equals 2? Bottom is not always going to be 0. Now we might have to washers. This one, this is what I would revolve. This is what I would revolve. And this would be your cross-sectional slice, which is why my radius is minus there, and I have y equals. So I have my top minus my bottom as my radius. Yeah. Oh, because I'm silly. And I was thinking of my semicircular cross-sections from Friday. Don't ask me why. Hi, it's yellow. That's cute. Okay. Thanks, Arya. So if I said to express the integral and not solve, that would be how you'd solve for it, right? Pi r squared because, good. It's not a semicircular region, it's a full circle. There we go. What's different with this guy, though? Find the volume when rotating the area between the following and the y equals -1. Ooh, about the y equals negative. Ooh. Nice thing is you have a picture. Oh yeah, wrong class, I'm sorry. Nice thing is you have a picture. But didn't the problem just get more complicated? What else do I need to put in my picture for sake of consideration? Yeah, the axis of revolution, which is going to be y equals -1, right? Counterclockwise, clockwise makes no difference as to the volume. I'm still going to do dx because I have a horizontal axis. What would change this to need a dy? Of some sort of vertical axis. Good. Either the y-axis that we're going about or some sort of x equals, as Aryan demonstrated. What's the problem about the region and the axis? What do I have in between? Space. So when region is not flush against, as this is going to be, if I just use this as my outer, my top, and this as my bottom, that would be a solid figure. I'm missing some. Some has been subtracted away. So in consideration of that, if you were trying to visualize the outer curve would be rotating. However, not just the outer curve, but also the inner curve, right? So that would be all hollow. This would be all solid. So this is what's revolving around in a solid fashion, and I have all that hollow area in between. And then I put some depth to it. That's going to take forever. You guys know the idea. It's a washer. I can stick my hand in and be totally fine. But how do we consider that? Well, think about your formulas. Whole minus hollow. Think if you had the entire whole thing. The entire whole thing. Uh-oh, I need my highlighter. Oh, Santo. Would have an outer edge of and an inner edge of. The hollow would have an outer edge of and an inner edge of. We have to think of these two three-dimensional figures separately. What if this was completely solid? Top minus bottom, no big deal. What if the hollow part was solid? Top minus bottom, no big deal. And then we subtract the two, like we do with SAT math, or you have done with SAT math. To get a whole where there's only a portion, you take like the whole and then the bigger and the smaller and subtract them in some sort of variation, some sort of order. So I need v equals pi. What are my bounds, though? What are my intersections, then? Three and 8? Is that what you said? It's not marked on my x-axis, right? So don't we have to do what we always do when it's not given to us? Set them equal to each other, yeah. When you subtract, that's a 2. When you divide by a negative, that's a positive 2, and then it's an 8. So I think x squared equals, maybe some of you got it. I'm sorry if I didn't hear it. 2 root 2 or root 8? Good job, Riley. So I'm going to go from negative. Now, if you were solving this by hand, would you have to go from negative 2 root 2 to 2 root 2? It's symmetric. So couldn't you go from 0, which is so much easier to plug in, to 2 root 2 and then double it? That works with volume, not just area, which is kind of nice. But we'll pretend that it wasn't something that we have to solve by hand. We either get to plug it into our calculator or express as an integral and stop. This is where so many mistakes happen. How do I do whole minus hollow? Do I just subtract and then square? Or do I square and then subtract? No. Square and then subtract. But maybe you were thinking the same thing. I don't subtract and then square and have one big old pi r squared. I have to have individual pi r squareds, one for the whole thing and one for the hollow. One for the whole thing and one for the hollow. So the whole thing, if it was solid, my top would be the function, right? What would my bottom be? Who is this guy again? So I have the whole thing. Oh, thanks. I just didn't put a minus. Oh, that's what I was thinking, though, because you square and then you subtract, as opposed to subtract and then square. So it's not big R minus little r. So you don't subtract and then square. You square and then subtract. So you square and then subtract. So I have my big R being my 4 minus x squared over 4 minus negative 1. So top minus bottom. The only reason I have to do negative 1 is because that's the axis I'm going around. So the very tippy top to the axis. outer edge to the axis, outer edge of the axis, outer edge of the hollow. Isn't that just 2? Oh. Ooh, minus -1, right? Could the AP leave it like that? I suppose. I think they would simplify it at least a little bit. How about you guys in your experience? What do you think? Yeah, we'll make it look a little bit nicer, I suppose. But I think they would leave it pretty close to this if you were just having to, unless they were to do the whole 2 in front, and then that gets a little bit confusing with the shells that we're going to see, hopefully, if we have time. We end up with 4 plus 1, which would be 5, right? 5 minus x squared over 4, quantity squared, minus 2 minus -1 would be 3 squared. But either way, you have to consider the entire solid and then punch out, aka subtract the hollow. So a pi big R squared minus a pi little r squared, and that's how you apply what you see here. We just pulled the pi out in front. Well, I guess I left it in there, but I pulled the pi out in front since it's in both terms. But I need a top minus bottom probably for the big R and a top minus bottom for the little r. So with me, oh, I changed it, never mind. Whole minus hollow. I used to do whole minus whole, and then it was confusing, like a donut hole, like you punch out. Anyway, whole minus hollow is so much easier. So here's my question. That'll be a great warm-up. What's different with shells? You guys saw in here, I had like some Khan Academy links, but you guys know how to find stuff that you need, I think, by this point. Especially those of you that look online a lot. So I don't think that's a huge deal. And plus, Khan has reordered his, so it's way nicer and way easier. And then Patrick JMT, it's more of a Googling thing for his. So let's go to shell. What is different? I already showed you last week the difference between adding up the discs on top of each other to make a volume and the shells. I need a better shell illustration. That one, they like shaved it and it is very imprecise. But with shells, here's what's weird, and here's where I call it, or why I call it, the para-shell method. Yes, I totally stole that from someone else. Perpendicular and para-shell. Perpendicular, you're always slicing thickness perpendicular to the axis of revolution. Shell method, you're always going parallel to the axis of revolution. This region is being revolved around this horizontal line. Discs and washers would say, hey, slice this way. Shells say, nope, take a hollow knife, whoosh, and then turn. That just sounds brutal if you're thinking about like a torture device. But as far as how this accumulates, when you do that, you end up with a cylinder. You end up with a cylindrical shell. And cylinders can accumulate also, similar to the illustration I was giving last week. I can add together a cylinder plus a cylinder. Actually, this would be a great way of doing it. You can kind of see it this way, right? Instead of slicing across like the discs, I'm slicing a cylinder. And a cylinder, and a cylinder, and a cylinder. But where's the axis? Parallel to the slicing. And that's where it gets confusing. Don't look at that side. That side's very not mathematical. Anyway, so coming back over here, what do we know about cylinders and their volumes? Aren't they pi r squared h's? Where's the thickness? Not here, but here. The thickness has to do with the representative rectangle that's going to be revolved, which is ironically parallel to the actual axis. And this brings us up to, wait a minute, well, how does that work? That's the volume formula of a cylinder. But remember how we make areas infinitesimally thin and then add a thickness. So maybe the question isn't getting a volume of a cylinder. Maybe the question instead is getting the surface area of the cylinder. And with the surface area, then giving it some thickness. We'll talk a little bit more about where the formula comes from. The perpendicular parashell is just about how you slice and in what terms you go. Obviously, we didn't get to finish the shell method today, so we're going to keep on going with that tomorrow. But here's a dealio. In homework, what do you want to be done with by tonight? Discs and washers, the stuff that you know. Whenever I ask you to do shells, just stop. Does that sound good? Okay. No, I'm going to take it off and make the deadline on Wednesday.
Wait, so do we not do homework on anything too?
No, we didn't.
We turned it in. Just do Friday. Yeah, when ASB was gone. Yeah, that was just the area one. That was just the area one. So if you guys want, if I were you, some of you took quite a bit of time to take notes today, right? Because you were doing a lot of sketches, et cetera, et cetera, et cetera. Take a quick picture of this on the way out the door. Have the formulas down and ready, and we're just going to practice them tomorrow. Sound good? Okay. So we'll start off with the back of our homework spiral. Do a quick, little bit tricky, what we skipped over in notes, back of our homework spiral, practice of discs and washers. Learn how to do shells. But have these notes ready to go. The little blop that's weird and written in is R. 2 pi RH. 2 pi R of X.
E to B or C to B? C to B.
C to D.
That didn't scare me. Oh my God.
Spirit of Christmas.